Hi folks, welcome to the Key Concepts Review for Quadratic Functions. That's Chapter 3 of the Math 521B or Pre-Calculus 11 course. We're looking at properties of quadratic functions here in vertex form and in standard form. There are a few disclaimers below you might want to read through. There's also a link to a downloadable copy of the notes in the video description below, and it might be useful to print that off and do the presentation along with me. Okay, let's dive in. Quadratics are polynomials of degree 2. That is, the highest power on x, or whatever the independent variable is 2. The shape of a quadratic graph is a parabola, and the turning point is called the vertex. So here's the shape of a parabola. Could either open up or down. They have properties that make them useful in optics, wireless communication, modeling the effects of gravity, and other things. And the most common form that you'll see them written in, or the three most common forms, are in vertex form, which surprisingly tells you the vertex, in standard form, which tells you some other stuff, or in factored form, which tells you x-intercepts. Now, not every parabola can be written in factored form because not every parabola has x-intercepts. You could already imagine one that might look like this. No x-intercepts, can't be put in factored form. We're going to start off by looking at vertex form. So what these parameters a, p, and q tell us, a tells us the direction of opening and the steepness. The p and q tell us that the vertex is at PQ, the point PQ. So we're going to use the y-intercept and the vertex to sketch this curve above, this curve right here. 3x minus 2 all squared minus 3. So first of all, we can say the vertex, it's at x minus 2, so the vertex has an x-coordinate of 2. Okay, it's whatever this is, whatever you're subtracting there, and a y-coordinate of negative 3. If we want the y-intercept for any curve, we just sub 0 for x. So that's going to be 3 times 0 minus 2 all squared minus 3, which would be 3 times 4 minus 3, or a y-intercept of 9. Now we can sketch this. 2, negative 3. 1, 2, 1, 2, 3. There's our vertex. Okay, and we're y-intercept at 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so the parabola looks like that. Now, it's symmetrical, so it also is going to contain the point 4, 9. Okay, it contained 0, 9, which was 2 to the left of the vertex. I'll have 4, 9, which is 2 to the right. There's a vertical line that splits the parabola down the middle, and that's called the axis of symmetry. And it's an easy one to get. Its equation is just x equals whatever the x-coordinate of the vertex is. Everywhere on that red line, x takes a value of 2. So that's going to be our axis of symmetry on this graph. The domain is just the x's in the parabola. So this parabola goes on forever to the right, forever to the left. The domain, you can write it as fancy as you like, is the set of all x such that x is a real number. The range, let's think about this parabola. It goes down to negative 3, but no lower. So if we were to say it, y's are negative 3 or greater. So y is the set of all y's such that y is greater than or equal to negative 3, and y belongs to the set of real numbers. So it follows that this parabola has a minimum value of negative 3. That's as low as it goes, right here. Okay, max and min are always y values. Let's try another one. We're going to sketch this We'll write the direction of opening, the coordinates of the vertex, the equation of the axis of symmetry, all this stuff. We could do this with a table of values, but let's do it with as little as we can get away with. So vertex on this one. The x-coordinate is always the opposite of what you see here. So notice in the last one we had x minus 2, and the x-coordinate was positive 2. Here we have an x plus 1. The vertex is going to be at negative 1, because it's like we're subtracting negative 1. And then it's just exactly what you'd expect for the y value. Okay, I could even start to sketch this. 2, 3. There's our vertex. Negative 1, 3. Okay, what else are we supposed to say? We're supposed to talk about the direction of opening. So negative 2 means it opens down. And the fact that it has a 2 in there means that it's kind of steep. Coordinates of the vertex we've got. Equation of the axis of symmetry. Well, let me just draw that axis of symmetry. It's going to go through the vertex. The axis of symmetry is going to be x equals negative 1. A vertical line always takes the form x equals. So to say a of s equals negative 1 would not be correct. X equals negative 1. The domain and the range, the max and the min values. We better get some more points on here. And the easiest one for us to find would be the y-intercept. Put in 0 for x. So y equals negative 2, 0 plus 1 all squared plus 3. Or negative 2 times 1 squared plus 3, which is just going to be 1. Okay, there's my y-intercept. It also follows that 1 to the left of the vertex, I'm also going to have that same y-coordinate. So negative 2, 1, and 0, 1. Now I've got a good idea of what the curve looks like. I'll sketch it. I can talk about its domain. The domain of a parabola will always go forever to the left and forever to the right, so it will always be the set of all real numbers. And the range here, the y's on this one, they go to 3 but no higher. In other words, they are all either 3 or less. So less than or equal to 3. And we should say which number system we're talking about, the real numbers. This graph has a maximum. Whenever it opens down, there's going to be a max. And the max value is 3. Let's try another one where we're going to actually write the equation given some information. We've got a parabola with a vertex at negative 1, 4. Maybe I'm going to sketch this a little bit. Negative 1, 4. And it goes through the point negative 2, 2. Okay, so it looks like this, apparently. If I were going to write its equation, I don't know what the a value is, but I know that it will take this form. I also know that a is negative. A vertex of negative 1, 4 means that I'm going to see an x plus 1, and I'm going to see a plus 4 at the end. Now we've got a problem. There are too many letters. There are 3 letters. We can only solve for 1. But we have one other piece of information. We know that the point negative 2, 2 satisfies this equation. So we can sub negative 2, 2 in so we can find a. Let's do that. So this is going to be an x value. This will be a y value. So 2 equals a, negative 2 plus 1 squared plus 4. This allows us to find a. A, negative 1 squared plus 4. Please don't go to your calculator to do negative 1 squared. That's just 1, so we get a is negative 2. And that makes sense. It does look like it opens down, and it should. So finally, we can take this initial statement and fix it up so that it has the proper a value. Negative 2 x plus 1 all squared plus 4. If you took some graphing application and plugged that in, you would get exactly the graph we're talking about here. A parabola that goes through that point and has that vertex. Let's take a quick look at a word problem. The path of a rocket is described by the function h of t is negative 4.9 t minus 3 all squared plus 60. Okay, hold on now. T is time in seconds, h is height in meters, and t is time in seconds after the rocket's fired. If I were to graph this, there's a time and there's a height. I'm not going to bother to actually draw it, but I could if I wanted to. What is the maximum height of the rocket? So at some point, it's a parabola, it goes up, it reaches a max. Am I looking for an x-coordinate or a y-coordinate of that vertex? Since it's going to be a height, I'm looking for the y-coordinate. From this form, I know that the x-coordinate, which is time, is going to be 3, and the y-coordinate of the max will be 60. So the max height of the rocket, 60 meters. Max makes you think vertex. Okay. When does the rocket reach this maximum height? Again, we're thinking vertex, but the when is going to be a t value. 3 seconds. Last piece of the puzzle. What was the initial height of the rocket? Initial should make us think time is 0, after 0 seconds have passed. So h at 0 is going to be negative 4.9, 0 minus 3, all squared, plus 60. And we've seen that function notation from grade 10. Okay, that'll be negative 4.9 times negative 3 squared plus 60. Negative 4.9 times 9 plus 60. And we can just run it through, and we're going to get 15.9. The initial height, which would be the y-intercept, is 15.9 meters. So chances are you're going to see some kind of question that involves using the max or min. And as long as you think vertex when you see max or min, we'll probably be okay. I find doing a quick little sketch helps me determine whether I'm talking about the x-coordinate or the y-coordinate. Okay, standard form, sometimes called explicit form. This is where it looks like a trinomial. A means the same thing it meant before. A is the direction of opening. And it's the steepness. Okay. C is going to give you the y-intercept. You don't even need to memorize that, because if you put in 0 for x, you'll just be left for C. Okay, here's the thing. This is not as useful for graphing, because you really want to know where that turning point is to be able to make the graph of a parabola. So some things you might want to know is that the axis of symmetry is at negative b over 2a. Or in your formula booklet, it gives you this. P is negative b over 2a. It's telling you that this is the x-coordinate of the vertex. Okay, negative b over 2a. The y-coordinate of the vertex is f at negative b over 2a. Meaning, just plug the x-coordinate into the function. Now, I'll show you another method to get the vertex in the next video. But I think this ends up being as straightforward as any, especially since you've got this piece of information, which is the same as axis of symmetry, in your formula sheet. So we're going to find the vertex of this, and then we're going to sketch. So we've said that the x-coordinate, or the axis of symmetry, is negative b over 2a. Okay, this is our a. The coefficient 2 is our a. 8 is our b. 9 is our c. So we'd have negative 8 over 2 times 2. Okay, that gives us negative 8 over 4, or negative 2. So the vertex has an x-coordinate of negative 2 something. The y-coordinate of the vertex is easy. We just sub that into the original function. 2 times negative 2 squared plus 8 times negative 2 plus 9. Okay, what's that going to give us? It'll give us 8 minus 16 plus 9, or 1. So the vertex is at negative 2, 1. We also know that the y-intercept is at 9. And if we weren't sure, again, we'd just sub in our regular stuff. We'd say, oh, y-intercept, I put in 0 for x. The y-intercept's going to be 9, or the point 0, 9. Now, hopefully this is all going to be consistent, because we expect that this opens upward and that it's somewhat steep. Let's see what happens. Negative 2, 1. That's our vertex. 2, 3, 4, 5, 6, 7, 8, 9. This is looking good. It does open upward. Okay. It's got an axis of symmetry at x equals negative 2. And it's going to do the same on the other side. Now notice, it contained the point 0, 9, which was 2 to the right of the vertex. So it'll contain a y of 9, 2 to the left of the vertex as well. And again, you could do this by table of values, but we've got enough to define the parabola just from that. Since the vertex of this quadratic is negative 2, 1, and the a value, well, is just 2, it follows that we could have written this in vertex form. It would just be y equals a value of 2, x, well, that's a minus 2, so you're going to see an x plus 2 all squared, plus 1 in vertex form. So by finding the vertex, you can easily convert, surprisingly, to vertex form. I'll show you another way to get there in the next video, but I really think this is sufficient. I hope that you found this helpful, and I'll see you for the next half. Take care.